Hello. This is an example of a DC mesh analysis analytical problem of level 1. So let's get started. It's asking us to use mesh analysis to express I naught and the power dissipated by the R3 resistor in terms of the mesh currents I1 through I4. The first step is to determine how many equations we're going to need. And this one seems pretty straightforward. We have 4 mesh currents, disregarding the outer mesh. And I don't see any control variables, so we're just going to need 4 equations here. Let's click submit. Now the first thing I look for are current sources. And I do see one at the top middle general area there. It's I1 going downward. And then it is also in between I1 and I3 mesh currents. So that's going to be the first equation we write. We can say that I1 is equal to, we see that I1 on the left mesh current is going in the same direction as the current source, while our I3 is kind of fighting against it. So the current source I1 is going to be equal to mesh currents I1 minus I3. So that's it for that. And that also turns I1 and I3 into a super mesh, but we're going to deal with that later. For now, let's go look at I2 at the bottom left. And for that mesh current, I'm going to solve for the voltages and do some KVL action. So if we look at the bottom there, the voltage across R5 using Ohm's law is going to be R5 times I2. And then we're going to add that with the voltage across the R4. And again, it's for voltage, it's current times resistance. So it's going to be R4 times I2 minus I4, because they're fighting against each other in the middle there. Set all that equal to 0. Now let's look at the bottom right mesh current, I4. Let's start with the voltage source on the right. And to find the voltage across that, we've got to look at what direction I4 is moving. And it is moving counterclockwise, which means it's going to hit the positive terminal of V2 first, and then the negative terminal. So the voltage across that is going to be a positive V2. Let's look at the R6 resistor there, compute the voltage across that, and add it. So the voltage across R6 is going to be current times resistance, or R6 times I4. Let's add that with the voltage across the R4 resistor, which is going to be R4 times I4 minus I2. And lastly, we have to deal with the R3 resistor, and the voltage across that is current times resistance. So we can add R3 times I4 minus I3. Set all of that equal to 0. And now we can take a peek at the super mesh. Start on the left and compute the voltage across the R2 resistor. And again, it's going to be current times resistance, or R2 times I1. Add that with the voltage across the R1 resistor. So it's going to be R1 times I1. Now the voltage across the V1 voltage source, we are moving clockwise direction here. So we're going to hit the positive terminal first. So we know that V1 is going to be positive. So we're going to add V1. Now the voltage across R3 is going to be current times resistance, or R3 times I3 I3 minus I4. And all of that is going to be equal to 0. Let's click submit. Looks all good. Now we write the equations for the stop variables in terms of I1, I2, I3, and I4. Let's look at I0 first. And I0 is on the top left here, pointing down. It is pointing in the opposite direction that I1 is pointing, and it is not attached to any other currents. So we know that I0 is going to be in terms of I1, nothing else, and it's going to be negative I1 because they're fighting against each other. So I0 is equal to negative I1. Now we look at the power dissipated by the R3 resistor. And let's take a peek at the webbook really quick. Let's see. The power dissipated by a resistor can be found by computing the current going through the resistor. And then we square that and multiply it by the resistance. So down here. So current squared across the resistor times resistance. And here the current across that resistor, since we're squaring it, doesn't matter what order we do it, but we do have to subtract these two currents because they are fighting against each other. So first let's take find the current. It's going to be I3 minus I4, and then we're going to square it. And we're going to multiply all that by the resistance, which is R3. And that should be good. Let's hit submit. Looks good. Thanks for watching, and I hope this helps.